The subcritical illusion synthetic Zeeman effect observations from galactic zoom-in simulations. Mass-to-flux ratios measured via the Zeeman effect suggest the existence of a transition from a magnetically subcritical state in heat clouds to a supercritical state in molecular clouds. However, due to projection, chemical, and excitation effects, Zeeman measurements are subject to a number of biases and may not reflect the true relations between gravitational and magnetic energies. In this paper, we carry out simulations of the formation of magnetized molecular clouds, zooming in from an entire galaxy to sub-He scales, which we post-process to produce synthetic high and low Zeeman measurements. The mass-to-flux ratios we recover from the simulated observations show a transition in magnetic criticality closely matches observations, but we find that the gravitational magnetic energy ratios on corresponding scales are mostly supercritical, even in the high regime. We conclude that He clouds in the process of assembling to form molecular clouds are already supercritical even before He2 forms, and that the apparent transition from sub to supercriticality between high and He2 is primarily an illusion created by chemical and excitation biases affecting the Zeeman measurements. MOMOVI multifrequency radio variability of the blazar AJ 287 from 2015-2022, absence of predicted 2021 precursor flare activity, and a new binary interpretation of the 2016-2017 outburst. Based on our dedicated SWIFT monitoring program, MOMO, AJ 287 is one of the best monitored blazars in the X-ray of optical regime. Here, we report results from our accompanying dense, multi-frequency radio monitoring of AJ 287 between 2015 and 2022, covering a broad range of activity states. Fermi gamma ray observations are added. We characterize the radio flux and spectral variability in detail, including and other variability analyses, and discuss its connection with the multi-wavelength emission. Deep fades of radio and optical fluxes are found to occur every 1 to 2 years. Further, it is shown that a precursor flare of thermal Bremsstrahlung long predicted by one of the binary supermassive black hole models of AJ 287 was absent. We then focus on the nature of the extraordinary, non-thermal 2016-2017 outburst that we initially discovered with SWIFT. We interpret it as the latest of the famous optical double-peaked outbursts of AJ 287, favoring binary scenarios that do not require a highly processing secondary sum. A search for 018 emission from intermediate velocity gas at high galactic latitudes. We present search results of 22 high-latitude sightlines for 018 emission using the 305 radio telescope at the Arecibo Observatory. These sightlines appear in neutral hydrogen emission at intermediate velocities and are predicted to have a sufficient molecular composition so as to be detectable in molecular emission. Such objects, known as intermediate velocity molecular clouds, have historically been detected through 12Co emission. Recent studies indicate that IVMS may be widespread in the galaxy and have important implications for models of the interstellar medium and star formation. However, we report non-detections of O emission toward the 22 sightlines and provide stringent upper limits on the O column density. Using available high and F data in combination with existing state-of-the-art per models, we estimate H2 column densities and find that they are more than an order of magnitude lower than the predicted values. We also find that the hydrogen volume density of these clouds is less than roughly 25 per cubic centimeter. In addition, we discuss the known IVMS with previous 12Co detections in the context of Thepter models. Our analysis of these clouds indicates that the structure of molecular material in IVMS is morphologically clumpy. These results motivate the need for future sensitive on the FLE searches for co-emission from IVMS with of order roughly 1 resolution. High angular resolution high-end of data will also be helpful to better constrain the structure and composition of IVMs. Curvature of the spectral energy distribution, Compton dominance, and synchrotron peak frequency in jetted AGNs. We collect a large sample with a reliable redshift detected by the Fermi satellite after 10 years of data, including blazars, ray narrow-line Seyfert-Horn galaxies, and radio galaxies. The spectral energy distributions of these Fermi sources are fitted by using a second-degree polynomial, and some important parameters including spectral curvature, synchrotron peak frequency, and peak luminosity are obtained. Based on those parameters, we discuss the Fermi blazar sequence and the particle acceleration mechanism. Our main results are as follows: by studying the relationship between the synchrotron peak frequency and the synchrotron peak frequency luminosity, jet kinetic power, and ray luminosity for jetted AGNs, we find an shape in the Fermi blazar sequence. There is a significant anticorrelation between Compton dominance, black hole spin, and the synchrotron peak frequency for jetted AGNs, respectively. These results support that the Nilssons and radio galaxies belong to the Fermi blazar sequence. On the basis of previous work, statistical or stochastic acceleration mechanisms can be used to explain the relationship between synchrotron peak frequency and synchrotron curvature. For different subclasses, the correlation slopes are different, which implies that the Fermi sources of different subclasses have different acceleration mechanisms. The Cirques and Nilssons have a higher median spin of a black hole than BLACs and radio galaxies. Alignment and rotational disruption of dust grains in the galactic center revealed by polarized dust emission. We aim to study the alignment and rotational disruption of dust grains at the center of our galaxy using polarized thermal dust emission observed by Sophia Hawke and Chimps Cupola 53, 216, and 850. We analyzed the relationship between the observed polarization degree with total intensity, dust temperature, column density, and polarization angle dispersion function. Polarization degree from this region follows the predictions of the radiative torque alignment theory, except at high temperatures and long wavelengths, where we found evidence for the rotational disruption of grains as predicted by the radiative torque disruption mechanism. The alignment and disruption sizes for the grains were found to be around 0.1 and 1 respectively. The maximum polarization degree observed was around 13 at 216 and comes from a region of high temperature, low column density, and ordered magnetic field. Magnetically, enhanced RAT alignment was found to play an important role in the grain alignment due to the presence of a strong magnetic field. RAT can lead to perfect alignment of the grains if they are superparamagnetic in nature. We estimated the mass fraction of aligned grains using a parametric model for the fraction of the grains at high attractors and found it to correlate weakly with the observed polarization degree. We observe a change in the polarization ratio from 216 850 mon to 216 850 mon at 35, which suggests a change in the grain model from a composite to a separate population of carbon and silicate grains as implied by previous numerical modeling. Pitfalls of a classification of rare objects galaxy mergers. In this proceedings, we will explore how galaxy merger classification can be improved by adding pre-extracted galaxy morphologies alongside the traditional imaging data. This demonstrates that current neural networks are not extracting all the information from the images they are given. It will also explore how the resulting samples of rare objects could be highly contaminated. This has a knock-on impact on the upcoming large-scale surveys like Euclid and Rubinholst. The Pridophylians around Messier 105. We undertook a search for new dwarf galaxies in the Leo group using the data from the Diepls Digital Ski Survey. 5 new presumed members of this group have been found in a wide vicinity of Mon 105. Currently, the group has a population of 83 galaxies, 33 of which have measured radial velocities. More than half of the group members belong to early types with no signs of ongoing star formation. About a quarter of the galaxies are outside the group's virial radius, or 385 kp. The presence of multiple systems with a size of about 15 evident in the group, but there are no noticeable global flat or filamentary substructures. The luminosity function of the group looks to be deficient in galaxies with absolute magnitudes in the interval of 18–15 mag. The Mon 105 group is characterized by a radial velocity dispersion of 136 keV, orbital mass estimate 1012 m, and the total mass-Toke band luminosity ratio mol. The neighboring group of galaxies around M66 has a similar virial radius, 390 kV velocity dispersion, 135 keV, and total mass to luminosity ratio mol. Both groups in the Leo constellation are approaching the local group with a velocity of about 100 ohm. In the background of the Mon 105 group, we noted a group of 6 galaxies with an unusually low virial mass to luminosity ratio (mTOC mol), active galactic nuclei with high-resolution X-ray spectroscopy. The imminent launch of XRISM will usher in an era of high-resolution X-ray spectroscopy. For active galactic nuclei, this is an exciting epoch that is full of massive potential for uncovering the ins and outs of supermassive black hole accretion. In this work, we review wide research topics that are certain to advance in the coming years with XRISM and prognosticate the possibilities with Athena and Arcus. Specifically, our discussion focuses on the relatively slow-moving ionized winds known as warm absorbers and obscures the iron emitting from different regions of the inner and outer disk, broad line region, and torus, and the ultrafast outflows that may be the key to understanding AG feedback. The AGNIFS survey spatially resolved observations of hot molecular and ionized outflows in nearby active galaxies. We present the hot molecular and warm ionized gas kinematics for 33 nearby X-ray selected active galaxies using the 22.12 ATEM and BR emission lines observed in the band with the Gemini near-infrared field spectrograph. The observations cover the inner 0.42 of each AGN at spatial resolutions of 4,250 keV, a velocity resolution of ins 20 kV. We find that 31 objects present a kinematically disturbed region seen in ionized gas, while such regions are observed in hot molecular gas for 25 galaxies. We interpret factor S being due to outflows with masses of 100 to 107 and 100–100 form for the ionized and hot molecular gas, respectively. The ranges of mass outflow rates and kinetic power of the outflows are 10·3·101 vir1 and 10·37·1043 erg for the ionized gas outflows, and 10·5·10·2 pi1 and 10·35·1039 erg for the hot molecular gas outflows. The median coupling efficiency in our sample is Cull 1.813, and the estimated momentum fluxes of the outflows suggest they are produced by radiation pressure in low-density environment, with possible contribution from shocks. Measurement of telescope transmission using a collimated beam projector. With the increasingly large number of Type Ia supernova being detected by current generation survey telescopes, and even more expected with the upcoming Rubin Observatory Legacy Survey of Space and Time, the precision of cosmological measurements will become limited by systematic uncertainties in flux calibration rather than statistical noise. One major source of systematic error in determining SNEA-collar evolution is uncertainty in telescope transmission, both within and between surveys. We introduce here the collimated beam projector, which is meant to measure a telescope transmission with collimated light. The collimated beam more closely mimics a stellar wavefront as compared to flat field-based instruments, allowing for more precise handling of systematic errors such as those from costing and filter angle of incidence dependence. As a proof of concept, we present measurements of the Stardust prototype telescope, achieving a standard uncertainty of 3 on average over the full wavelength range measured with a single beam illumination. GNOME's analysis of the galactic diffuse molecular ism in all 4 ground state hydroxyl transitions using MOBA. We present observations of the 4,2π3,2 ground rotational state transitions of the hydroxyl molecule along 107 lines of sight both in and out of the galactic plane, 92 sets of observations from the Arecibo telescope and 15 sets of observations from the Australia Telescope Compact Array. Our Arecibo observations included off-source pointings, allowing us to measure excitation temperature and optical depth, while our ATCOB observations give optical depth only. We perform Gaussian decomposition using the automated molecular excitation Bayesian line fitting algorithm MOBA, fitting all 4 transitions simultaneously with shared centroid velocity and width. We identify 109 features across 38 sightlines. While the main lines at 1665 and 1667 tend to have similar excitation temperatures difference 0.6, 84 show text difference took. Large differences in the 1612 and 1720 mass satellite line excitation temperatures show that the galaxies generally similar different For a selection of sightlines, we compare our O features to associated cold gas components identified by Nguyen et al. And find no strong correlations. We speculate that this may indicate an effective decoupling of the molecular gas from the CHEM once it accumulates. An atlas of color-selected quiescent galaxies at 3 in public JOST fields. We present the results of a systematic search for candidate quiescent galaxies in the distant universe in 11 JOST fields with publicly available observations collected during the first 3 months of operations and covering an effective scale area of 145 arcmintu. We homogeneously reduce the new JOST data and combine them with existing observations from the Hubble Space Telescope. We select a robust sample of 80 candidate quiescent and quenching galaxies at 3s, 5 using 2 methods based on their rest frame of colors, and a novel quantitative approach based on Gaussian mixture modeling of the Neuville, Huove, and Vage rest frame color space, which is more sensitive to recently quenched objects. We measure comoving number densities of massive quiescent galaxies consistent with previous estimates relying on ground-based observations, after homogenizing the results in the literature with our mass and redshift intervals. However, we find significant field-to-field variations of the number densities up to a factor of 2-3, highlighting the effect of cosmic variance and suggesting the presence of overdensities of red quiescent galaxies at 3, as it could be expected for highly clustered massive systems. Importantly, JOST enables the robust identification of quenching quiescent galaxy candidates at lower masses and higher redshifts than before, challenging standard formation scenarios. All data products, including the literature compilation, are made publicly available. Estimating stellar parameters and identifying very metal-poor stars using convolutional neural networks for low-resolution spectra. Very metal-poor stars offer a wealth of information on the nature and evolution of elemental production in the early galaxy and universe. The upcoming China Space Station telescope will provide us with a large amount of spectroscopic data that may contain plenty of stars, and thus it is crucial to determine the stellar atmospheric parameters for low-resolution spectra similar to the spectra. In this paper, a two-dimensional convolutional neural network model with 3 convolutional layers and 2 fully connected layers is constructed. The principal aim of this work is to measure the ability of this model to estimate stellar parameters on low-resolution spectra and to identify stars so that we can better search for stars in the spectra observed by TRIXT. We mainly use 10,008 observed spectra of stars from LaMostre 3 and 16,638 spectra of common stars from LaMostre 8 for the experiment and make comparisons. All spectra are reduced to 200 to match the resolution of TRIXT and are preprocessed and collapsed into two-dimensional spectra for input to the model. The results show that the May values are 99.40 for TEF, 0.22 dex for log, 0.14 dex for phi, and 0.26 dex for chi, respectively. Besides, they can model efficiently identifies stars with a precision of 94.77. The validation and practicality of this model are also tested on the Marx synthetic spectra. This paper powerfully demonstrates the effectiveness of the proposed model in estimating stellar parameters for low-resolution spectra and recognizing rump stars that are of interest for stellar population and galactic evolution work. The halo mass temperature relation for clusters, groups, and galaxies. The halo mass temperature relation for a sample of 216 galaxy clusters, groups, and individual galaxies observed by Chandrax Ray Observatory is presented. Using accurate spectral measurements of their hot atmospheres, we derive the MET relation for systems with temperatures ranging between 0.4–15.0 keV. We measure the total mass of clusters, groups, and galaxies at radius 2500, finding that the 2500 relation follows a power law with 1.65 0.6. Our relation agrees with recent lensing studies of the MET relation at 200 and is consistent with similar theoretical prediction in recent simulations. This agreement indicates that the MET relation is weakly affected by non-gravitational heating processes. Using lensing masses within 200, we find 200 follows a power law with slope 1.61 0.19, consistent with the 2500 relation. No evidence for a break or slope change is found in either relation. And trade and yeah. Potential bias is associated with sample selection, evolution, and the assumption of hydrostatic equilibrium that may affect the scaling error examined. No significant impacts attributable to these biases are found. Non-cool core clusters and early spirals produce higher scatter in the matrillation than cool core clusters and elliptical galaxies. The cosmic timeline implied by the JOST high redshift galaxies. The so-called impossibly early galaxy problem, first identified via the Hubble Space Telescope's observation of galaxies at redshifts 10, appears to have been exacerbated by the more recent James Webb Space Telescope discovery of galaxy candidates at even higher redshifts, which, however, are yet to be confirmed spectroscopically. These candidates would have emerged only 230 million years after the Big Bang in the context of requiring a more rapid star formation in the earliest galaxies than appears to be permitted by simulations adopting the concordance model parameters. This time compression problem would therefore be inconsistent with the age-redshift relation predicted by Lyell. Instead, the sequence of star formation and galaxy assembly would confirm the timeline predicted by the Rohat universe, a theoretically advanced version of ULTIM that incorporates the zero active mass condition from general relativity. This model has accounted for many cosmological data better than ULTIM and eliminates all of its inconsistencies, including the horizon and initial entropy problems. The latest JOST discoveries at 14, if confirmed, would add further support to the idea that the Rohat universe is favored by the observations over the current standard model. Characterizing the conditional galaxy property distribution using Gaussian mixture models. Line intensity mapping is a promising technique to constrain the global distribution of galaxy properties. To combine LIM experiments probing different tracers with traditional galaxy surveys and fully exploit the scientific potential of these observations, it is necessary to have a physically motivated modeling framework. As part of developing such a framework, in this work we introduce and model the conditional galaxy property distribution, i.e., the distribution of galaxy properties conditioned on the host halo mass and redshift. We consider 5 galaxy properties, including the galaxy stellar mass, molecular gas mass, galaxy radius, gas phase metallicity, and star formation rate, which are important for predicting the emission lines of interest. The KICT represents the full distribution of galaxies in the 5-dimensional property space. Many important galaxy distribution functions and scaling relations, such as the stellar mass function and Fermat sequence, can be derived from integrating and projecting it. We utilize 2 different kinds of cosmological galaxy simulations, a semi-analytic model and the illustristic hydrodynamic simulation, to characterize the KICT and explore how well it can be represented using a Gaussian mixture model. We find that with just a few Gaussian components, one can describe the KICT of the simulated galaxies to high accuracy for both simulations. They can be mapped to LIM or other observables by constructing the appropriate relationship between galaxy properties and the relevant observable tracers. Identifying active galactic nuclei at 3 from the HETDEX survey using machine learning. We used data from the Hobby-Eberly Telescope Dark Energy Experiment to study the incidence of AGN in continuum-selected galaxies at 3. From optical and infrared imaging in the 24 Dagtu Spitzer HETDEX Exploratory Large Area Survey, we constructed a sample of photometric redshift selected 3 galaxies. We extracted HETDEX spectra at the position of 716 of these sources and used machine learning methods to identify those which exhibited AGN-like features. The dimensionality of the spectra was reduced using an autoencoder, and the latent space was visualized through to distributed stochastic neighbor embedding. Gaussian mixture models were employed to cluster the encoded data, and a labeled dataset was used to label each cluster as either AG, stars, high redshift galaxies, or low redshift galaxies. Our photometric redshift sample was labeled with an estimated 92 overall accuracy, an AGN accuracy of 83, and an AGN contamination of 5. The number of identified AGN was used to measure an AGN fraction for different magnitude bins. The of absolute magnitude where the AGN fraction reaches 50 is MOV 23.8. When combined with results in the literature, our measurements of AGN fraction imply that the bright end of the galaxy luminosity function exhibits a power law rather than our with a relatively shallow faint end slope for the 3 AGN luminosity function. A lensed radio jet at milli-arcsecond resolution EA constraints on fuzzy dark matter from an extended gravitational arc. Using a single gravitational lens system observed at 5 milli-arcsecond resolution with very long baseline interferometry, we place a lower bound on the mass of the fuzzy dark matter particle, ruling out 4.41021 eV with a 21 posterior odds ratio relative to a smooth lens model. We generalize our result to non-scalar and multiple field models, such as vector F with Vec 1.41021 eV. Due to the extended source structure and high angular resolution of the observation, our analysis is directly sensitive to the presence of granule structures in the main dark matter halo of the lens, which is the most generic prediction of F2 theories. A model based on well-understood physics of ultralight dark matter fields in a gravitational potential well makes our result robust to a wide range of assumed dark matter fractions and velocity dispersions in the lens galaxy. Our result is competitive with other lower bounds from past analyses, which rely on intermediate modeling of structure formation and/or baryonic effects. Higher resolution observations taken at 10 to 100 Gauss could improve our constraints by up to 2 orders of magnitude in the future. Multiverse predictions for habitability element abundances. We investigate the dependence of elemental abundances on physical constants and the implications this has for their distribution of complex life for various proposed habitability criteria. We consider 3 main sources of abundance variation differing supernova rates, alpha burning in massive stars, and isotopic stability, and how each affects the metal-to-rock ratio and the abundances of carbon, oxygen, nitrogen, phosphorus, sulfur, silicon, magnesium, and iron. Our analysis leads to several predictions for which habitability criteria are correct by determining which ones make our observations of the physical constants, as well as a few other observed features of our universe, most likely. Our results indicate that carbon-rich or carbon-poor planets are uninhabitable, slightly magnesium-rich planets are habitable, and life does not depend on nitrogen abundance too sensitively. We also find suggestive but inconclusive evidence that metal-rich planets and phosphorus-poor planets are habitable. These predictions can then be checked by probing regions of our universe that closely resemble normal environments in other universes. If any of these predictions are found to be wrong, the multiverse scenario would predict that the majority of observers are born in universes differing substantially from ours, and so can be ruled out, to varying degrees of statistical significance. Exploring the morphologies of high redshift galaxies with machine learning. The morphology of a galaxy has been shown to encode the evolutionary history and correlates strongly with physical properties such as stellar mass, star formation rates, and past merger events. While the majority of galaxies in the local universe can be classified on the Hubble sequence, little is known about the different types of galaxies we observe at high redshift. The irregular morphology of these galaxies makes visual classifications difficult, and with the future of astronomy consisting of many big data surveys, we need an efficient and unbiased classification system in place. In this work, we explore the use of unsupervised machine learning techniques to perform feature extraction from galaxy images to separate high redshift galaxies into different morphological types based on the machine learning clusters. We expand on previous work by addressing observation biases such as the orientation, apparent size of the galaxies, and noise before extracting features, thus reducing the number of clusters and forcing the network to learn meaningful features. We then compare the extracted clusters' physical properties to investigate the separation between the groups, simulating the local web anomalies in the local density field. Context: several observations of the local universe point towards the existence of very prominent structures. The presence of massive galaxy clusters and local superclusters on the one hand, but also large local voids and underdensities on the other hand. However, it is highly non-trivial to connect such different observational selected tracers to the underlying dark matter distribution. Methods: we used a 500 a large constrained simulation of the LU with initial conditions based on peculiar velocities derived from the cosmic laws to catalogue and follow galaxy formation physics directly. In the hydrodynamical simulations to base the comparison on stellar masses of galaxies or X-ray luminosity of clusters. We also used the 2668 large cosmological box from the Magneticum simulations to evaluate the frequency of finding such anomalies in random patches within simulations. Results: we demonstrate that halos and galaxies in our constrained simulation trace the local density field very differently. Thereby, this simulation reproduces the observed 50 underdensity of galaxy clusters and groups within the sphere of 100 when applying the same mass or X-ray luminosity limit used in the observed cluster sample, which is consistent with a 1.5 feature. At the same time, the simulation reproduces the observed overdensity of massive galaxy clusters within the same sphere, which on its own also corresponds to a 1.5 feature. Interestingly, we find that only 44 out of 15,635 random realizations are matching both anomalies, making the LU to be a 3 environment. We finally compared a mock galaxy catalogue with the observed distribution of galaxies in the LU, finding also a match to the observed factor of 2 overdensity at 16 as well as the observed 15 underdensity at 14 distance. A search for transients in the reionization lensing cluster survey 3 new supernova. The reionization cluster survey imaged 41 galaxy clusters with the Hubble Space Telescope in order to detect lanced and high redshift galaxies. Each cluster was imaged to about 26.5 mag in 3 optical and 4 near-infrared bands, taken in 2 distinct visits separated by varying time intervals. We make use of the multiple near-infrared epochs to search for transient sources in the cluster fields, with the primary motivation of building statistics for bright caustic crossing events in gravitational arcs. Over the whole sample, we do not find any significant caustic crossing events in line with expectations from semi-analytic calculations, but in contrast to what may be naively expected from previous detections of some bright events, or from deeper transient surveys that do find high rates of such events. Nevertheless, we find 6 prominent supernova candidates over the 41 fields. 3 of them were previously reported and 3 are new ones reported here for the first time. Out of the 6 candidates, 4 are likely core collapse, SNE3 in cluster galaxies, and among which only 1 was known before, and 1 slightly behind the cluster at 0.6-0.7. The other 2 are likely IA, both of them previously known, 1 probably in a cluster galaxy, and 1 behind it at 2. Our study supplies empirical bounds for the rate of caustic crossing events in galaxy cluster fields to typical ACE magnitudes, and lays the groundwork for a future rate study.